Hey guys, what's up? It's Chris with Invictus Cockpit Systems. I have probably the coolest thing that I've done since I started building flight simulators, and I'm going to tell you about it right now. All right, guys, it's finally ready. The AIM network is ready for release. Now, this has been a labor of love, hundreds and hundreds of hours, thousands and thousands of dollars, and God knows how many PCBs I've thrown in the trash in the search for the perfect way to make this system. And I finally found it. And I can't wait to share it with you guys. So let me tell you what the AIM network is, or a little history about it. About 2.5 years ago, I started making, started trying to build the AIM network. And I was making a RS-485 system that worked in conjunction with DCS BIOS. And I kept running into roadblock after roadblock after roadblock. I was spending money to try to get it upgraded and having developers that really know what they're doing, trying to fix things with it. And I just couldn't get it to do what I wanted it to do. So about 8 months ago, I started over and I created a Power over Ethernet system. Now, Power over Ethernet, when I say that, is not like a lot of the YouTube videos and tutorials out there that talk about Power over Ethernet, but it's really just power injected to a Cat6 cable that will fry if you plug it into the wrong thing. This system is a true, this is a mouthful, bear with me for a moment, IEEE 802.3AT Type 1 Class 0 compliant Power over Ethernet system. It provides 12.95 watts of power to each of the powered devices, and it can do a whole lot, as you're going to see here in a few minutes. But you can connect all your switches, all your instruments, all your backlighting, all of that stuff can be run through this system, and it will work like a dream. Watch the rest of this video. I'm going to walk you through the software, the Cockpit Manager software. Man, I'm struggling today. The Cockpit Manager software and the different power devices. So we have 3 power devices right now. We have the AIM Sidewinder, which is our main board. It has 46 input outputs. It has a couple of different channels for I2C and SPI communications, depending on how you want to build your cockpit parts, or you can obviously buy the cockpit parts from us that will definitely work with the system. We also have a bigger I2C breakout board called the Phoenix that offers 8 channels of I2C. And then we also have the AIM Sparrow, which is an 8-channel relay board. So those of you guys that need to actuate servos or more high voltage switches, this will allow you to control that with the software and with DCS BIOS or BMS as well. Anyway, without further ado, let's jump into the software so you can see it. Okay, first up, we're going to install the network settings. The software automatically detects that you don't have an IP address assigned to it, so it's going to automatically assign the IP address and set your system up to run as a server for the software. You will have to give it admin privileges, but other than that, it's very simple to do, and you're good to rock and roll pretty quickly. Next up, we're going to connect a new AIM Sidewinder board to the device or to the system, and it's going to give you, after a few seconds when it goes through the connection process, it's going to give you a pop-up that shows that a new board's been detected, and you're just going to click the configure now. I'm going to go ahead and load an imported config that I've already done here to speed things up. But if you do go through it, you're going to type out the board name in the board wizard here. And forgive me, this takes forever because I'm one finger typing it and I mistyped it. My bad. But you're going to type that out. Then you're going to go on to the next page by clicking the next button, and it's going to bring up a list of all the panels. You're going to select the ones you want for that board, and then you click next again. It's going to bring up all the pins. You can use the default pins, or you can select whichever ones you want. It won't allow you to overwrite them or use them twice. You're going to click save and upload. That's going to export the pins to the board, and then you're going to click export pinout, and that's going to produce an HTML document that has all the pins and switches listed, so that when you go to wire everything up, you'll have it dialed in pretty strong. Again, one finger typing, trying to do multiple things at once, my bad. But once you get it up, you can see that it's pretty cool. It's got a little list of the pins that you are using next to the switch names. Makes it really, really easy for wiring. And you can print that off and keep it in a book or something so that you always have a reference. Now, once that's finished, you're going to want to click Request Diagnostics. And in this example, you can see that we returned a fail warning for one of the GPIO expanders. Now, it would turn out that that GPIO expander was not properly installed. It didn't reflow correctly, and some of the pins weren't connected. So I pulled the board, got it on my workbench, resoldered it, got it going, and then boom, good to go. Then we're going to fix the DCS installation. We're going to click Setup DCS Lua. It automatically finds the location of your saved games folder, and then you click Install, and all the Lua files are automatically installed. Super easy. Okay, let me show you how the potentiometer calibration works. We got it all connected. We're going to mess with the flood consoles knob on the lighting panel, and you can see how turning it just a little bit, a quarter turn, wraps this thing all the way to full range. We don't like that. We want the range to match the actual potentiometer turning. So we're going to open the calibrator. We're going to turn the potentiometer back and forth a few times, and then once that looks good, we're going to click Save, and that's going to essentially save the range of motion. And when we turn it now, you can see a full resolution turn gives us the entire range of motion so that it's finely controlled and it doesn't peg out way too early. And while we're here, let's jump over to the HUD panel and test out some switches, make sure those are working properly. And yep, looking good. So we'll move on to the next thing. BMS is a little more complicated, so we need to set up a bunch of virtual joysticks to make it work properly because of the way BMS is configured. So we're going to click the the BMS button. It's going to create 10 virtual joysticks, and those virtual joysticks will all be assigned different functions by the software. Nothing you have to do. You do have to give it admin privileges, though, to make this happen. Takes a couple seconds, let it run through its process. It'll close automatically, and you'll be good to go. The next thing you need to do is launch BMS, and then I'm gonna walk you through real quick on how to install the key file. So it's already automatically generated. Click Setup, go to Controllers, click Load, and then it'll pull up your list of key files. Select the Invictus AIM key file, and OK, and that's it. Click Instant Action or whatever flight model you want, and click Commit, and you're off to flying. Enjoy. Next up, I'll show you how to set up MFDs in the system. So you're going to click the MFD button, and then you just select which MFD you want. Select the monitor that's already connected. It'll automatically detect it, all its sizes and everything. You're going to click Write DCS Lua. It's going to write a custom Lua for it, install it. You take note of that resolution there, and you're going to go into DCS and select the appropriate settings there. Once you get it launched up, you're good to go. Give me just a second while it loads. Should have clipped some of this out, but I didn't, so bear with me. All right, so you can see that it automatically pops up the MFD where it's supposed to be, and it's already working. So that simple. No hand reworking anything. You just click the buttons in the software and it fixes everything for you. One last thing to show you is the stepper motor calibration. for gauges. So you go, you find the stepper motor, right click on it, enter the calibration menu, and you can set the number of steps, the offset so that you can make sure the zero's in the right place, tell it how far the gauge sweeps, all that stuff, and it'll work perfectly for you straight out of the gate. It's super easy to use. Happy flying, guys. All right, guys, that's the software side of the AIM network and the Cockpit Manager software. Now I want to talk to you about the hardware. So this is where I make my money, because I'm going to give you the software for free, but this hardware is going to be for sale. This is the AIM Sidewinder. This is kind of the flagship of the AIM network. It is a 46 GPIO board, several headers. It has breakouts for 12 volt, 5 volt, 3.3 volt, and it also has 2 channels for I2C communication and 2 channels for SPI communication. So it can pretty much run whatever you build, provided you wire it correctly, and things like the address on the I2C and things like that. They don't overlap with the addresses on the board. You'll need to read the data sheet to make sure you have everything in line. But you can use our hardware, of course, or if you build your own, you'll be able to use the AIM network. One of the additional things that we added is 6 backlighting channels. So these produce 12 volts. They're controlled by a PWM pin on the microcontroller. So you can control your backlighting. And what that does is you have all of your LED backlighting, your console. You can also program a different one to do your console lighting, your flood lighting, and all that stuff. Instruments. You can have it all set up differently depending on how you organize everything. But this allows you to, when you turn the knob in your sim, the physical cockpit lights dim, the virtual cockpit lights dim, and it all works simultaneously together. So it's a really cool little thing. Does exactly what we want it to do. I had some footage of it, but I can't find it. I'll post some later in like a short or something so you guys can see how that works. The next board is the AIM Phoenix. The AIM Phoenix is smaller, and it's mostly for I2C communication. It has 8 separate I2C communication channels. That way, especially, when I was designing this, was envisioning the center pedestal. You've got all your instruments and various things that are going to need their own little breakout boards. So you can design things with I2C communication and run a wire back here, and this board will control it all. It also has 16 GPIOs on board, just in case, you've got, one of the instruments that has, one switch or one knob, and you want to be able to handle everything at one time. This will allow you to do that. It also has 4 backlighting channels on it. So that's this guy. And then the last one is the AIM Sparrow. This is our relay board. This one requires one of the other 2 because it runs on I2C communication. So if you pair it with a Phoenix or Sidewinder, you would just run one of the I2C channels here over to this guy, and that will allow you to control high voltage switching for things like if you have a seat actuator that lifts and lowers your seat, and you want to control it with the switch in your cockpit. This will allow you to do that safely and efficiently. It can also do other things like servos. If you've got the real magnetically controlled switches, it can run up to 250 volts. So it can handle quite a bit of current and voltage. So it's going to be pretty useful for those of you that are building real cockpits. But that's pretty much the gist of the hardware right now. If you go look at the software, you'll see in the bottom left corner, it talks about, the stick grip, and it says no device. So what that is, I am very close to releasing a 5th generation VFT, a throttle, and eventually rudder pedals. They're all going to connect through this software as well. They use a different communication protocol, completely different firmware. This is all proprietary built-in house firmware. And it does a lot of really advanced things, and really, it's a really awesome product, if I'm being honest. That's going to come out soon. I got good news and bad news with that. If you have a Gen 4 or later and you want to upgrade, all you have to do is buy that little board and plug it in and you're good to go. Anything earlier than that, I'm sorry, there's no way to make it work with this device. But you know, if you want it refurbished or re-upgraded or something, you can send it in and I can most of the time upgrade it to the newest generation. It's going to cost a little bit, but it's better than having to buy a whole new one, I guess. Or you can buy a Gen 5 if you want and get those in your hands. But that is all of that. That is all the AIM network stuff. Now, I want to invite you guys to do something. I want to invite you to follow, especially if you don't already, because I'm about to start a series where I show you how to build every single part in the F-16 cockpit, start to finish. We're going to build everything there is, and I'm going to show you everything I know about building it and what I've learned over the last 4 or 5 years and all the money that I've spent and stuff. Now, I want to be honest, a lot of the stuff that I've acquired to build stuff commercially, you may not have access to. So I don't want you to think I'm going to show you this really fancy way of building it and you're just going to be able to do it, because some of you may not have the equipment to do it, but you can pull some things from it and kind of help you in your journey to build a cockpit, because this is a marathon, not a sprint, as I'm sure you know. But anyway, don't forget to subscribe. You guys have a good one. I'll see you soon. Oh, one more thing. I almost forgot. Right now, the AIM network is set up for the F-16. However, the infrastructure is there to create all of this for anything that is in DCS or BMS. So right now, DCS and BMS are all that's set up. I also have plans to include Microsoft Flight Simulator, X-Plane, and Prepare 3D. And then we're going to add several different planes. I hope to add them pretty soon. You know, I want to hit the FA-18. I want to hit the A-10. I want to hit the upcoming F-35. There is a guy that is working on a mod, a full function or full fidelity mod. Well, full fidelity is close as you can get with an F-22. I have an F-22 simulator in the back, so I'm really looking forward to that. So we're going to make it work with those too, and a couple other planes, the F-15, the F-14. We're gonna try to hit all the highlights, and then maybe what we'll do is some kind of vote for your favorite plane or whatever, and we'll do them in order, because each one's going to take a little while to do. But in the comments section, if you want to see something other than an F-16, tell me what it is, and maybe I'll pick one of you at random and just start working on that plane next. Now I'm really done. See you guys later.